1 mole of ideal gas undergoes a linear process as shown in the PV diagram. Find its temperature as a function of volume. And also we have to find out that how does the temperature vary during the process. Just look at the graph. If you get any type of graph, first you try to recognize the equation that can be set up by looking at the graph. It's a direct y equal to mx plus c pattern of the straight line. So let's try. P is equal to m. M means the slope. So slope is equal to the y by x, is it not? And that also negative. That is minus p naught by v naught into v, and then the y-intercept is P naught, so plus P naught. And they have said 1 mole of an ideal gas. So 1 mole means PV is equal to RT. Is it because N is equal to 1? I am writing again. PV is equal to RT. So therefore, our job is to find out the temperature versus volume. So we need to eliminate the pressure. So why not we write P is equal to RT by V. So if I write P is equal to RT by V here in this place, we have RT by V is equal to P naught minus P naught by V naught times V. We just cross multiply by V and then divide by capital R. So what do we have? We have T is equal to P naught by R times V minus P naught divided by V naught R times V square. Then if you wish, you can take common or you can leave the answer there also. It depends upon the options that might have been given in the question. The question has been taken up just as a small subjective question where you can get a idea about just how to express the temperature versus volume. So you can take a common. T is equal to how much it will be? P naught V divided by R. You may keep V inside the bracket also. So it becomes within bracket 1 minus and one of the V will be there divided by V naught. Now they are asking how does the temperature vary during the process. By looking at this graph, you are able to see that if I plot a temperature versus volume graph, the graph will be parabolic and opening downward, is it not? So parabolic open downward. So if you try to draw a temperature versus volume graph at v equal to 0, t equal to 0, although t 0 is very absurd here, so you have like this. So that means you can say that the temperature first increases and then it decreases. The temperature increases and then decreases during this process. It can also be understood by drawing many isotherms. If you draw isotherms, then what will happen? The more the distance from the origin, the greater will be the temperature. So one of the isotherm may lie on P naught and V naught like that. So you can say that as we are moving from one point to the other point along this process, the temperature increases somewhere in the middle, near about the middle, the temperature will be maximum and then the temperature decreases. That's the nature of variation of temperature with volume.